Just realized I forgot to hit record, so a little bit late to this. So we did 0. 0 over 1 gave us 0. Here at pi over 4, anything over itself is going to be 1. So you're not going to have to plot weird square roots. It's going to come out to nice numbers. All right, at pi over 2, y over x. So 1 over 0. Good. And that means that there is a asymptote. Good. Now at 3 pi over 4, now we're right here. Anything over itself is 1, but this time it's going to be -1. Very good. And then at pi, it will be 0. Now, I'm not going to draw out. Now we're going to go backwards. I'm not going to draw these out. I think we can just talk our way through it. When you go to negative pi over 4, that would be right here. What would you get for that one? Oh, is it 1 or is it -1? I know it's like, I know it's 1. It's -1. Good. And negative pi over 2, you're going to be down here. -1 over 0 is undefined. Very good. Now, this one a little tricky. When you're at the -3 pi over 4, that's, oh, why is that +1? Good job. Negatives cancel. And then at negative pi, you're going to get 0. So we're going to plot these and you're going to get to see a new shape. Okay? Can you guys cut it out? All right, so we're going to plot these. You get 0, 0. Pi over 4 is 1. I'm not going to slide the paper up and down because I'm going to end up making you see thick. You guys have it in front of you now. Pi over 2 is an asymptote. And then we had -1, 0. And that's the pattern. It's going to go -1, 0, 1, asymptote. -1, 0, 1, asymptote. -1, 0, 1, asymptote. So when you go backwards, the negative pi over 4 was -1. And then we had another asymptote. And you can keep on going. Like, again, they're cyclic, so you can fill up the whole thing. Like I can put another point here, here, and here, and then another asymptote. And what you get are an infinite number of these wiggly things. If you call them cubic, I'll forgive you. They're technically not, because this is not a cubic function. It's a tangent function. But I get why that happens. But you get an infinite number of these little wiggles. Give me that. Give me that. I will give it back to you at the end of class. All right, so some things that we noticed about this. First, let's do domain and range. And one of those is actually really simple and sort of a gimme question. What is your range? It's everything, right? Domain is annoying because you have to leave out the asymptotes. Do you remember how it starts? Because we did it with secant and cosecant. Oh, good. All x and then yeah, this like the no parking sign, like the not equal to. You guys make my job so easy because you remember stuff that I've said previous classes. It's awesome. So you take the first asymptote and it's either 0 or the first positive one. So where is that? This one right here, right? Where is that? That's pi over 2. And you're going to put plus however often they occur. So let's see. We have one at negative pi over 2, positive pi over 2. Every pi they are happening. And so good, we put pi n to show that it's going to happen forever and ever. All right. I'm going to say a couple more things. This is an odd function. And again, that doesn't matter this unit, but I keep bringing it up because it's going to matter in the future. To review, sine was odd, so cosecant was also odd. They go together. Cosine was even, and so secant was also even. So this is odd. Maybe put stars next to this. Your amplitude is none. Amplitude is a word that by definition only applies to a wave. So the only ones that have it are sine and cosine. All the other ones are none, which is a gimme answer, but also you have to remember it. And then I feel like I was going to say, oh, one other thing, and maybe put stars next to this as well. The period is pi. That's a change. For all the other ones, it was 2 pi, but for this one, you only go halfway around the circle. So that's like actually the biggest thing is you have to remember it's only 1 pi instead of 2 pi, which is easy, but also easy to forget. So you got to be careful. So let's flip it over and we're going to do cotangent. It's going to be the exact same thing, but when you go around the circle, how do you get your values? Instead of y over x, it's going to be x over y, but same thing. Bless you. All right, so start here at 0. Bless you. That would be 1 over 0, which is undefined. That'll be an asymptote. At pi over 4, anything over itself is 1. At pi over 2, 0 over 1 is 0. What is 3 pi over 4 going to give us? -1. And then pi, -1 over 0 is undefined. And then we're going to do the same thing going around backwards. I'm not going to draw these lines in, but when you go to negative pi over 4, it'll be -1. Down here, it'll be 0. Over here, again, it will be +1 because they're both negative, so the negatives will cancel. And then at negative pi, good, another undefined. So we're going to take those and put them on the grid. It's going to be wiggly things again. As a heads up, though, do you see how these ones are increasing? Cotangent, they're going to be decreasing. Okay, so you're going to take those points and plot them, but just as a heads up, they're going to be going down. So at 0, we have an undefined. And then it's going to go 1, 0, -1, and then another asymptote. And that's the pattern. 1, 0, -1, asymptote. And you can keep going forever. I mean, it's just going to keep doing the same thing. They're cyclic, so it keeps on going. So to recap, we have either a wave or we have the smiley faces and frowny faces, like those U shapes, or we have these wiggly things. So again, we're going to do the same stuff. Domain and range. And your range will be everything. And the domain, you write it the same way, but it's not going to be the same exact answer because this starts in a different place. So it'll be all x except, now where's the first asymptote on this one? Yeah, 0 pi. It's nice when it's 0. It's always nice when stuff's 0. Plus, however often they're happening. So you have one at negative pi, 0, positive pi. So again, it's every pi they're happening. So plus pi n. It's going to be odd. They go together. No, I want to talk about that. They go together. So like, for example, sine was odd, so cosecant was odd. Cosine was even, so secant was even. If tangent was odd, then cotangent is also odd. What's the amplitude? None. It is a gimme answer, but you have to remember that. That's only for a wave. And again, the period is just 1 pi instead of 2 pi, and that's the important thing you've got to remember for these. So let's go over to the notes example. We'll try a couple of these and then we'll do like a couple minute break. But these are going to be the ones that are all transformed. So we've stretched and shrunk them and shifted them around. And the process hasn't changed. It's just your period is 1 pi instead of 2 pi. Now we're going to have to wait on the domain, but range, we can actually answer that without a picture because it's everything. If you know it's going to be that wiggly shape, then you can just go ahead and answer that. And then what else can you answer on there? Amplitude is none. We can actually answer all of it except the domain. Period. Do you remember how before we did 2 pi over whatever? This time it is just 1 pi over, yeah, whatever. And it's absolute value of whatever's in front of the x, which is 1/2. So if you divide by a half, that's same as multiplying by 2. Good. So it'll be 2 pi. So you just have to remember that you start with 1 pi instead of 2 pi. That's all. Which again, it's easy to do, but it's also easy to forget to do. So you got to be careful. Phase shift is your left or right. Do you see anything added or subtracted in there? No. So 0 or none. And in fact, I'm going to put 0 pi. So I remember to put the pi in there. And then vertical translation is up or down. Do you see anything added or subtracted out there? No. So you can say 0 or none. What goes in your first little window here? I know a weekend happened since last time I saw you. Yeah, your phase shift, so 0 pi. And then you add the period because you want to go 1 cycle. So, and it's nice when it starts at 0, 0 plus 2 is 2. So 2 pi. Halfway in between those is 1 pi. And then this will be pi over 2. Isn't that nice? It turned out to be like the unit circle ones. But it doesn't matter what those say, because we're going to just go around our circle anyway. Now for these ones, you're only going to go halfway around, and we're going to take whatever we get from our unit circle and multiply it by 2 and then add nothing. It's like a plus 0 at the end. So basically whatever we get, we're going to multiply it by 2. How do you get tangent? Good, y over x. All right, here we go. And you always start at the beginning. 0 over 1. 0 times 2, 0. Now we're here with the square root of 2 over 2. That's 1 times 2. Yeah, it doesn't matter what it says there. We're just going to go around the circle. This one just goes halfway around. Now we're at the top. 1 over 0, undefined. And then we're here with the square root of 2 over 2 thing, except that's going to be negative 1 times 2 will be negative 2. And the last one is always back where you started. You always end and start at the same place again because they're cyclic. Now we have to count by halves. So what I would do is skip the first tick mark and call the next one pi. So you don't have to label every single one of them. Don't let me forget to go back and answer the domain. That's a common thing that happens, and I every once in a while will do it too, because you feel like you're done after you get the graph. Don't forget to go back and answer everything. All right, so we get 0, 0. And then pi over 2, 2. And then an asymptote. And then the next one's negative 2, and then the next one's 0. Now, we kind of didn't like finish a whole wiggly thing. So watch me point to this. This is negative 2, 0. What's the next one? At 2, and then what's the next one? Asymptote, good. And I want to see at least 2 wiggly things, at least 2. So here's one of them. And then if I complete this one, I'm going to have a point down here at negative 2, and then another asymptote. And you can, of course, draw more. I just need to show you, take 2. I need you to show me at least 2 of them. That wasn't too bad, right? Bless you. Oh, thank you. Don't forget the domain. It's going to be all x. I almost did after I just got done preaching about that. All x not equal to, where's the first asymptote? It's either 0 or the first positive one. So good, pi plus, now let's see, we have one at pi and then 3 pi. So plus 2 pi. Gosh, you guys have got that. And yeah, good. This is going like so well. Like this year, this unit is just going really well. You guys have got it. We'll do one more and then we'll do a little break. Now I messed this one up pretty good. First thing I'm going to say is, do you see how there's a -2 out front? I will go ahead and tell you that usually ends up bothering a lot of people because it's out front instead of at the end. So the first thing I'm going to tell you to do is scribble that out and put the -2 at the end. I don't know why, but I mean, I guess I do know why. It's because it's in a different place. But that will really throw people off. So scribble that out and put it at the end. Here's the second thing. Do you see the 4 in front of the x? You have to factor that out. If you don't factor it, you can't see what the phase shift is. So I'm going to go ahead and write this out blank. and give you a chance to copy it as well. And then we're going to factor out. Do you remember GCF, greatest common factor? You have to factor that out in order to see what the phase shift is. If you don't factor that, you can't see the phase shift. So I kind of just left it blank, and then we can factor that out. So you're going to put a 4, start a parenthesis, and you have to divide out a 4. Your greatest common factor is 4. So what would be left for this when you divide out a 4? Yeah, x minus pi over 4. And then we can go and start filling all this in. And you want to look at the factored one, so I'll just cover this up. What can we go ahead and answer? Range is everything, which is nice. No amplitude, that's none. I feel like when you answer these, it's just, I mean, they're each worth a point on the test. It's like ka-ching, ka-ching, points, points, points. All right, what else? Now, instead of 2 pi over whatever, it's just pi over absolute value, whatever's in front of the x, which is 4, which would just be pi over 4. So here's what happened. Instead of being pi, we squished it or compressed it to pi over 4. It got very compressed. Do you get what I'm saying? We took it like a vice and just squished it. All right, phase shift. You have to look at the factored version. It's left or right, so it's kind of backwards. It went right pi over 4. So you can just put positive pi over 4, or you can write RIGHT pi over 4. And then this is your up or down. Yeah, down 2. You could say -2 or just write down 2. Don't let me forget to go back and answer the domain. That's a common thing. All right, what goes in our first little window? Good, your phase shift, pi over 4. Hey guys, it's not 0 this time. Okay, but you guys have done well with the fractions, so I believe in you. Now you're going to add the period because you want to go 1 full cycle, which weirdly is also pi over 4. Those turned out to be the same number. So a 4th plus a 4th is a half. Let me talk you through this. We're going to have to break down the 4ths. So real quick, how do 4ths break down? 8ths. That's going to get us to the middle. We're going to have to break them down again to get here. So how do 8ths break down? Okay, good. You came with me on that. Let's just off to the side write these as 16ths. 1/4 would be how many? Good. Nice. 4/16 is what that one is. A half would be how many? Be 8/16. So what goes halfway between 4 and 8? 6/16, which that reduces, but at that point, I don't care if you reduce that or not. 6/16, and then what's going to go in this one? 5/16, and then this one would be 7/16. Do you see how it was just counting 4, 5, 6, 7, 8? 4, 5, 6, 7, 8. They're just all 16ths. Good, you survived. That was the hardest part of the problem. 4/16, 5/16, 6/16, 7/16, 8/16. All right, I'm going to cover that up though, because at this point it doesn't matter. We're going to go around the circle. How do we get tangents again? Y over x. And hold on, let me line this up nicely here. And that's going to give us this part. So after we get that value, what do we have to do to it? This is what we get from the unit circle. Multiply it by a half and subtract 2. Okay, so the first one is going to be 0 times a half. 0 minus 2, -2. All right, what's the next one? Now we're here. 1 times a half minus 2 is -1.5. Then we're up at the top. What do we get from that one? Good, and you can't do anything to an undefined. Like you can't subtract 2 from an undefined, right? And then what's the next one? Now we're over here at this point. -1 times a half would be -1/2 minus 2 would be -2.5. And then what's the last one? Yeah, back where you started. So -2. Now we have to count by 16ths. How would we do that without labeling every single one of them? Count to 16. I don't know if it'll go far enough. 1, 2, 3, 4. Oh, it fit. Go to the 16th one and call that pi. I would maybe go to the 8th one and call that pi over 2. Just so you at least have one more of them labeled. But at this point, I now know that they're all 16ths. So we're going to go to 4/16. That's the fourth little tick mark, and that'll be -2. So go to the fourth one. That's our 4/16. We're going to start there at -2. And then the fifth one, the 5/16, is -1.5. And then an asymptote. Are we counting okay? I like seeing people count on their fingers like that. I do that constantly. All right, and then the next one is -2.5, and then -2. And that's everything we got from the table. So we didn't finish like a whole wiggle. So let's do the next one. This is -2.5, -2. Where's the next one? Yeah, -1.5, and then another asymptote. And then you do the same thing going the other way. And you have to show me at least 2, which you'll get 2 out of that. So you just keep the pattern going. What do we have to go back and answer though? The domain. You are going to be so bummed out if you leave it blank on your test. I am too. All right. So it is all x except, where's the first +1? Well, look, it's at the, oh, good. It's at the second tick mark. So that's 2/16, which is 1/8. So pi over 8. If you wrote 2 pi over 16, I would mark that right though. At this point, if you get the right answer, I'm just so happy. So I don't need that reduced. Plus, however often they happen, they're happening every 4 tick marks. That's 4/16, which is pi over 4n. If you wrote 4/16 though, fantastic. If you got the right answer, I'm thrilled. Okay. Do you have a question? I know everybody's just like super tired and we're like spring break is coming, but are we like, okay, we're chilling. So this process is going to be the exact same thing, but because it says cotangent, when we go around the circle, how do we get the values? X over y. I mean, like, other than that, it's the same process. So what are the things we can fill in? Let's do like all the automatic stuff. Yeah, amplitude will be none, and range will be everything. And I make these worth 10 points each, and so you're like, hey, I got 2 out of the 10 points already. All right, now the period, instead of 2 pi over whatever, for tangent and cotangent, it's just 1 pi over absolute value of what. Oh, and we are going to have to factor this one. I got so excited to start the problem, I didn't factor it. It's going to go over whatever's in front of the x, which is 2. So it'll just be pi over 2. But let me stop and go back and factor that, because you can't get the phase shift unless that's factored. So we're going to have to factor out a 2. So I kind of just left it blank there. So if you factor out a 2, greatest common factor of 2, what would be left? Yeah, x minus pi. That was kind of nice because they both had a 2 in them. And so your phase shift is left to right. So remember, it's kind of backwards. It would be what? Pi, 1 pi, or you could say right pi, or just put a positive pi. And then I heard somebody say this one already. Up 1, or you could just put 1. So that's half the points of the problem right there, which is cool. All right, what goes in the first little window? Pi, which is your phase shift. It's like you're shifting to where you started. And then you're going to add the period because you want to go one cycle. So we're going to add pi over 2. So this is pi plus pi over 2. That would be 1.5 pi, but we don't say that. It would be 3 pi over 2. So let's see. We're going to have to break down the halves into, what do halves break down into? Fourths. That number, the fourths are going to break down into eighths. Okay. So pi would be 8 eighths. Like 1 whole pi is 8 eighths. This would be 12. God, you guys are so good with the fractions. 12 eighths. And at that point, you can kind of just count 8 eighths, 9 eighths, 10 eighths, 11 eighths, 12 eighths. Are you seeing that there? Like 8 eighths. This next one is 9 eighths. This is 10 eighths, 11 eighths, and then that's 12 eighths. I really don't care if you reduce them at that point. Like if you get the correct fractions, I'm just thrilled. So like leave it, it's fine. The only one that would reduce anyway is the 10 eighths. So would that be if you really want to put 5 fourths, fine. But at the end of the day, because that's the hardest part, if you can't get that, make something up, you can still get the rest of it without those numbers. We're going to go around the unit circle, and then what will we do to those numbers? Add 1. There's nothing out front, so we don't need to multiply by anything. We're just going to add 1. So whatever we get, we're going to add 1. All right, x over y, 1 over 0. Yeah, you can't do undefined plus 1. It's just going to be an asymptote. All right, what's your next one? 1 plus 1, so 2. Then we're up at the top. That would be 0 plus 1, so 1. Hey guys, focus. This one will be -1 plus 1 would be 0, and then undefined. I don't eat that much sugar first thing in the morning. That would be sick. All right, you have to count by eighths. Look, you have to count by eighths. So go to the 8th tick mark and call it pi. Go to the 8th one and call that pi. And then I guess you could go to the 4th one and call that pi over 2. I'd like for you to like label at least 2 of them for me. But now I know each little tick mark is an eighth, like a ruler. And then we'll go ahead and plot those. So at pi, you're going to have an asymptote. And then at 9 eighths, you'd be at 2, and then 1, and then 0, and then another asymptote. Now here is the thing. I want to see another one of those. You should continue it to the left. And actually, I think we're going to need to do 2 more of them, because when you go back to do the domain, you need the first asymptote, which means we need to get back to this axis. Are you following me there? Because it might, actually, I think this one lands on 0. So we're going to have to follow it back this direction. So we're going to go right here. This will be 0. And then 1, and then back up to 2. Or did you follow? Like, we're just walking this pattern backwards. Do you see what I'm doing here? I don't know. I feel like a pattern is not something I can like force you to see. I can kind of like present it and show it to you and be like, do you see it? But are you guys able to continue the pattern? Are we good there? Okay. Like without coming around and looking at everyone's paper, I have no way of doing that. But you have to be able to get the first asymptote. So you want to walk it back to the left if you're not close to the axis. Was that enough wait time to draw that? Okay, all right. So all x except, where's the first asymptote? Get 0 pi plus however often they're happening. So we have one at 0, and then the next one's at pi over 2. So plus pi over 2n.